Hello everyone. I hope you had a great summer vacation, but summer is almost over and it's time to get back to our rendering focused series dedicated to V-Ray for Revit. This is episode 3, where we will explore some more specific workflows considered as advanced. Once again, I'm Anna from Chaos Group. Thank you all for joining, and let's start. In our previous episodes, we found out that V-Ray for Revit is an easy, powerful, and fast plugin which allows you to create photorealistic images straight out from Revit. In episode 1, we explored 5 reasons why V-Ray for Revit can contribute to your workflow. In episode 2, we explored a typical workflow. We learned how to set up the materials and lighting, how to create and add proxies, how to generate graphs, how to transfer V-Ray settings between users or from one computer to another one. For those of you who have missed any of these webinars full of invaluable info, I would like to say that they have been recorded and you can find them on CTC's YouTube channel. In today's webinar, I have so much to share with you guys that we might run out of time, so please be patient. We will start with materials, we will familiarize with the very standalone material editor, and we'll learn how to create and modify V-Ray materials. We will then continue with a few approaches to boost the realism of our renderings. Last but not least, I will show you how to run a distributed rendering using V-Ray Swarm, which can significantly decrease your render times. At any point, if you have any questions, please drop a line in the GoToWebinar chat panel, and Josh and Kiefer will handle your questions all the time. Starting with materials, V-Ray for Revit installs along with a library of ready-to-use V-Ray materials. They are optimized to work best with the V-Ray engine. The materials are organized in 20 categories suitable for the purposes of architectural visualization. They are very simple to use, just drag and drop, and currently the library consists of 554 materials. We are working on extending it with even more materials because we know that you love them. So let's first open Revit, and then let's look at the library. So it installs by default in program files, Chaos Group, V-Ray, V-Ray for Revit, VRMAT editor, materials, and here you can find different categories like bricks or concrete, glass, and so on. For those who want to have their own and unique materials, the V-Ray standalone material editor comes in handy. It is installed along with V-Ray for Revit, and it can be found in the VRMAT editor folder, or it can be launched from the V-Ray for Revit UI, which I will show you in a while. The idea behind the VRMAT editor was to be an easy-to-use tool for modifying V-Ray materials or creating new ones from scratch. So let's open Revit. I have this funny scene that I have prepared, and we will use it to create a few wall cladding materials for the front wall. Okay. Like this. While creating those materials, we will also explore different design options. So what I will start with is that I will run an interactive rendering. I will move the progress window to my other monitor so that it doesn't distract us. And now I will open the asset browser because I want to change the material of the front wall, the one over here. And I know its name is wall 2. So I'll search it, and then I will open the library. And we'll go to wood. And I will take this one and we'll drag and drop it. Now each V-Ray material has a recommended map size, which you can follow, or you can experiment a bit until you like the result. In my case, I will put this to 100. And then the next thing that I will do is that I will open this material in the V-Ray standalone material editor by clicking this button over here. Here it is. We have already seen it in episode 1, and probably you already know, but I will remind you that the editor is organized into 2 tabs, basic and advanced, and most of the parameters that you will need while modifying a material can be found in the basic tab. If you want to go advanced, or if you want to create a new material from scratch, then you can use the advanced tab. Now, the first thing that I will do with this material, since I want to modify it, is that I will save it under another name. So let's say it is wall cladding 1. Save as. And we're ready. So what I want to do with this material is that I will show you how to work with the opacity and displacement options. So displacement is something similar to bump, but what makes it different is that it adds geometric detail to the material. So it adds relief to the material by adding geometric detail to it. So I will enable the displacement, and clicking here, I can add a map. And this is a list of all maps that are available in the V-Ray standalone material editor. You can select among some procedurally generated textures, or you can add a bitmap. So I have a bitmap, so I will select this option, and here's the pattern that I have. Now I will decrease the texture placement to 0.3, like this. And to see it better, I can select a wall close-up. And I will stop my interactive rendering because I want to see what happens here. I will also decrease the displacement amount because a value of 1 might be too high. So I will set it to 0.1. Waiting for the preview to update. But basically we are ready to save the material. And then I will go back to my rendering, and I will enable render region so that we can render only the area that is around the wall. This will also save us time. And what I forget was to drag and drop our new material here. It is very easy. Simply click on the preview and drag and drop it over the asset browser, and the material will be assigned. Now render. And there we go. And as you can see, the shadow here, we really have geometric detail. If we have used bump instead of displacement, we would have had a flat shadow here. And now it is, it has this relief, the same as the pattern. Another thing that I would like to focus your attention is that currently the pattern is not aligned perfectly. So what we can do is that we can go to the orthographic 3D view, and here I have the wall and I have a model pattern assigned to it. So if I select a line from the pattern, like this one, and if I move it with the arrows on my keyboard, like up and down, this will update the rendering and will align our material. Like this. Okay, so now I will stop the rendering. I will go back to the material we just created, and I will delete the displacement, clear, and turn it off. So we have again this base material that we started from. And since many users ask how to create wood batten, now I will show you an approach that can be used to create wood batten. So we will use opacity, and we will click on the map here, and we will select gradient map. Gradient map is a multi-purpose map which can be used in many different situations. So now we will use it to create stripes, and basically you need to set the type to U and the interpolation to none. And now moving these dots over here, like this. And now under texture placement, I will set this to 10, and here are our stripes. So wherever we have, at the places where we have black, this part of the material will be taken away. And basically this will be the result. And now if I save the material and re-render, here's what we have. And in some cases, as seen from the shadow here, in some cases you will need to combine the opacity with a small portion of displacement in order to avoid this gap in the shadow here. Okay. And now the next thing that we will do, I will stop this again and go back to the material, remove the opacity. And now I will, so in the diffuse slot, we have this wood texture. I will go back, and by right clicking here, I will copy that texture. Then I will go into the texture menu, and I will select tiles. And in the color tile slot, I will paste the wood texture. So basically we now have tiles in wood pattern, and I will change the mortar color to something more brownish. Okay, now we have this wood tiles, and then I will go to opacity and I will select tiles again. And for the color tile, I have this image that has dots pattern. Basically, this will create a perforated material. So we will create a kind of a perforated cladding, like big tiles that are perforated. But here in the count, I will put 1 like this. And I forgot to do it here as well. Okay, and the last thing, we'll go to the bump, and in the bump slot we will also assign tiles. The color should be white here and black here. And now if we change the preview, here's what we have. I will save it, and I'm ready to re-render the image. The tiles are slightly bigger. So what I will do is I will go to the asset browser again, find the material, and I will play with the map size. I know that in this case, something like 54 by 54 would work for me. And I need to slightly adjust the positioning. Like this. Okay, so a few more words with regards to the material editor. Most of the parameters in the basic tab are self-explanatory, like the diffuse color is the actual color of the material. It can be either color or a texture map. Reflection specifies the amount of reflection for the material. So basically, the darker the color, if it is set to black, there is no reflection, and the brighter the color, the more reflective the material would be. Reflection glossiness controls the sharpness of the reflections. A value of 1 means perfectly polished surface, and decreasing the value will blur the reflections. Refraction glossiness, IOR, fog color, and multiplier refer to glass materials and to transparent materials as well. Basically, the refraction controls the transparency of the material, and the brighter the color, the more transparent the material will be. Similarly to reflection glossiness, the refraction glossiness parameter controls the sharpness of refractions, and a value of 1 means perfect glass-like refractions, while lower values can help us create frosted glass. For example, we can browse a material from the library to show you. Here it is, and the refraction glossiness is set to 0.8 instead of 1, and we have this frosted glass effect. The IOR means index of refraction for the material, and it describes the way light bends when crossing the material surface. A value of 1 means that the light will not change its direction. And bump, I think we're familiar with it. This will add relief to the surface of the material. Now I want to jump back to my presentation. I will close these materials and I will stop the rendering for a while because I want to show you also how to use VRScan materials. So here we are. And VRScans, we started supporting them in version 3.6. So since then, V-Ray for Revit is compatible with VRScans. These are our ready-to-use photorealistic scanned materials, and we use a scanning technology to scan real-world materials. How it works: an existing object is being photographed from hundreds of angles and directions. The scanner captures the texture information, dimensions, and the most important thing, the unique way how the material actually reacts to light. And later on, this guarantees that the material will behave like it should under all kinds of lighting conditions. These materials are very easy to use, drag and drop. All of them are seamlessly tileable, and the library is being constantly updated. As far as I know, at the moment, it contains over 650 scanned materials. They are available for download on our website. You need to go to the downloads section and you need to log in prior to this. And there is a separate VRScan section where the VRScan library can be found. Here you can explore different materials, and when you click on a material, you can see it very detailed. Yeah, so I have downloaded some VRScans in advance, and if we go back to Revit, and let's find, this is, okay, so this is the next scene that I have prepared. We have this armchair that is actually an RPC model, which is replaced by a V-Ray proxy at render time. We'll have to wait for a while until the rendering starts. As we spoke in the previous episode, proxies don't have a visual representation in the Revit viewport. That's why in the Revit viewport we see the RPC, but once we render, we see the proxy that I have used. So now opening the asset browser, going to proxies, and I need to click on the armchair to activate the filter so that there is nothing else in the list. And here we are. Now here are my VRScans. and I only need to drag and drop them. Be careful because every VR scan comes with a PNG preview, and sometimes users are confused, and instead of drag and dropping the VR scan, they take the PNG. So here I have a fabric VR scan and a wood. And something happened and my Revit just crashed, so I will have to restart it. Sorry for this, guys. It was unexpected. But these are the risks of the live demo. It can happen. Okay. Here we are. Acquire license. And this time I will have to drag and drop the VR scans once again. Like this. Then I will render. Here we are, here are our VR scans, and what we can do now is just adjust the map size. And in order not to wait for the rendering, I can show you how it looks like when rendered in high resolution. I will stop the rendering now, and here is the image. So this is how VR scans look like when rendered. Okay, now let me open the next scene. And we will start with the next topic, the atmospheric effects. In the previous episode, we explored just for a while the environment tab of the V-Ray for Revit settings, and we learned how to use the infinite ground plane. And this time we will look at the aerial perspective and environment fog options in the environment tab. So I will run a rendering. Here we are. I have this cute little forest house, and the image looks nice, but the trees on the background, they look flat, and basically there is no depth or sense of distance, while in reality you know that distant objects become pale compared to those that are observed from a closer distance. To simulate this, we use either aerial perspective or environment fog. Understanding how these settings work is not super difficult at all. So I will start with the aerial perspective and will enable it. There are three parameters, and note that they are key to the Revit project units. So whatever units you're using in your Revit project, the same will be used for the atmospheric height and the view distance. So basically, the atmospheric height defines the height at which the aerial perspective effect starts, and it spreads downwards. Lower values can be used for artistic effects like fog and haze. And what I will do now is that I will decrease the value here to 300. The view distance, as the name suggests, is the distance further from which we will barely see any objects, as 90% of the light coming from them will be absorbed by the fog. So if we change the view distance to a smaller value, the fog will come closer and the opposite. But in our case, I see that it is too dense. So what I will do is that I will increase the view distance to some 5,000. So that only the trees at the background appear slightly pale. And finally, the in-scatter multiplier controls the amount of light scattered from the fog. The default value of 1 is physically accurate, while lower or higher values can be used for artistic purposes, and higher values make the fog appear more dense. So now I will increase the in-scatter multiplier to 1.6. And here we are. Now let's disable the aerial perspective, and we will jump to the environment fog. In terms of rendering, this effect is more accurate and realistic, while aerial perspective, on the other hand, is faster. So I will enable the fog, and I will start with defining the height and the particle distance. The height works the same way as in the aerial perspective. Starting from it, the fog spreads downwards. Basically, the higher the height, the darker the rendering, because the sun is blocked by a larger amount of fog. This can be corrected by increasing the particle distance. So let's explore their values. But first, I will slightly decrease the exposure value because the image is quite dark. So let's make it something like 12. And let's see what will happen if we put the height to 10. Or to 25. We see that the fog is visible at the background. And now, playing with the particle distance, I will decrease their value to create a fog that is more dense. So I will start with 200 and see what happens. Then I will change this to 100. And at the end, I will input 50 meters. Now let's focus on the checkboxes below. By default, affect background and affect secondary rays are enabled. Affect background enables the tracing of background rays. At that moment, we see fog at the background here, where the sky is. So basically, the background is affected by the fog. And if we disable this option, we will be able to see the sky. I will keep it enabled. And affect secondary rays enables the tracing of secondary rays through the fog. What this means, basically this means that the fog will be visible in reflections, refractions, and shadows, and disabling it might speed up the rendering on the expense that it will become physically inaccurate. Okay, so now let's jump to the color parameters, and I will explain what the difference between color and emission color is. So the color parameters defines the fog color when illuminated by light sources like environment or artificial lights. In our scene, we are using a sun. So I will pick up a red color so that it is well visible on the rendering. As you can see, the fog becomes red. And if we enable the use artificial lights option, V-Ray will take them into account while rendering the fog. So basically the fog will be illuminated in red by the sun and by the artificial lights as well. Now the difference between color and emission color causes the fog to illuminate both itself and the objects around it. It acts as a self-illumination parameter. Think of it like the self-illumination parameter in materials. And the emission multiplier controls the intensity. So right now in our case, the image is quite dark and the fog is not well visible except in the background. And instead of decreasing the exposure value to make the image brighter, I will now increase the fog's illumination by increasing the multiplier to something like, let's say, 5. Now the fog is better visible. We can see it also in the foreground, and we can also change its color. Like this. And at this moment, I think that we can increase the particle distance so that we don't have that much fog to the foreground. So something like 150. We can play with the color. And I think we managed to cover everything related to environment effects in V-Ray for Revit. And we can jump to the next topic. Since I'm not entirely sure if we will have enough time for everything, I have switched some parts of my presentation, so now I will continue with lens effects. And if we have enough time, we will continue with V-Ray Swarm. I hope we will have. Okay. So I have this oil refinery scene, and I have rendered it in advance. So I will open the VFB. I will open the VFB history panel, and I will browse to the location of my rendered images. Here is the image that I already have, and it looks quite good. However, if we have taken it with an actual camera, we would have some bloom and glare effects around all bright spots. In V-Ray, we can simulate bloom and glare with the help of the lens effect settings, which are accessible from the VFB, from the button over here, bottom toolbar, and the button on the right. So starting with the bloom effect, in reality, blooming occurs when capturing extremely bright light. Camera sensors usually cannot process the entire amount of light, and a halo appears around the light source. I will now enable the bloom, and we can see this soft glow that appears around all lights on the image. Note that when we apply lens effects to the image, a new channel called Effects Result appears here. It is created in the VFB, and we can use this button over here to switch between the effects result and the RGB image, like this. Now the mode of the bloom controls whether the bloom will be applied to the RGB image stored in a separate render element or both. I usually set it to image and render element. The weight controls the strength of the interpolation between the bloom effect channel and the original image. And as you can see, lower values make the effect almost unnoticeable, while higher values make it way stronger. So I will set this to something like 25. Okay. And the size parameter controls the size of the glow as percentage of the image width. So higher values result in more blurred bloom, like this, while lower values make the halo visible, like this. So in our case, I think that a value of around 50 would work good. And the shape parameter controls the fall off of the bloom. Higher value decrease the radius of the halo and make it more distinct, but I will keep this to a lower value of 2, for example. And I will also enable the intensity parameter. Basically, this controls where the bloom effect will be applied on the image based on pixels intensity. And if you go with the mouse over the image and click and hold the right mouse button, there is a small window that appears with the pixel information. Well, in my case, it appears on the other monitor. But doing this, we can check the pixel value of the brightest areas on the image and then key the intensity parameter to that value. And in my case, I will set the intensity parameter to 2. And now let's continue with the glare effect. Glare introduces the starry look that results from light passing through the camera lens and creating a flare around the light source. You can see I can disable it again and enable it. So basically these stars here are created by the glare effect. First, we need to specify the type, i.e. how the glare is computed, and there are three options: from image, from render camera, or from camera parameters. And as the name suggests, from render camera uh, generates the glare based on the render camera settings. So I will switch to glare type from camera parameters, and the parameters down here will be unlocked, and we will be able to modify them in order to modify the shape of the stars that we see on the image. So before changing the camera parameters, a few words about the mode, weight, and size. They work the same way as with the bloom effect. So yeah, we have again this mode: image only, image and render element, or render element only. Uh, and the weight and size work basically the same way. I will keep this to 30. Now the camera parameters. The F number controls the strength of the glare effect, or how nice the stars will appear. By default, it is set to 8, but let's see what happens if we set the value to 1. The stars become very thin and small, and if we increase the value, they become larger, but also blurred. So for my scene, I think that a value of 4 would work well. Okay, perfect. And the blade parameter controls the number of rays that the stars will have. I can change it to 4 just to show you what happens. There are only 4 rays of the star. And I will set it back to 6. And you can also use the blade's rotation parameter to rotate the stars, but I will keep the angle of 15, the default value. Another way to create the glare is from an image. Then we need to set the glare type to from image. And to create the image that we will use, we can use one of the V-Ray for Revit tools that come along with the V-Ray for Revit installation. So they are in C program file, scales group, V-Ray for Revit tools, and we will use the filter generator. This is a simple tool that allows us to create different patterns for the glare effect. So basically there are controls for the flare shape, for the number of rays, and we can create a simple pattern. The number of lines depicts the number of rays, like this. And down here you can see the final preview that the lens flare effect will have when applied to the image. So let's save it. Basically the image images for the glare effect are saved in an HDR format, so you need to click File, Export HDR, select the image size, and save it. Now load the glare image. And we will need to decrease the weight. And probably the size as well, a little bit. And I think we have covered almost everything related to lens effects. A few more things to mention. The controls for object ID and material ID are not supported in V-Ray for Revit at that moment. When the hardware accelerated option is enabled, every change that we make to the lens effects will be seen immediately, just the way we did it now. And in case this option is disabled, you will have to click the Update Effects button every time you change a setting. In V-Ray Next, the lens effects controls were reduced and simplified, and starting from our next major release, V-Ray Next for Revit, we will also support them. So basically they will become even easier to use. And let's go back to my presentation for a while. And okay, I will start now with V-Ray Swarm, and let's see if we will have time for it. Okay. Swarm is the very distributed rendering system, which allows you to render on multiple machines at once using a simple web interface. Um, Surely your local office has a huge amount of computer power that you're not using. Well, in case you're working in a studio in an office environment, while basically every machine on the network has the potential to contribute to rendering. With V-Ray Swarm, you can utilize every computer resource that your local network has to offer. Furthermore, V-Ray Swarm manages all these resources in a smart way so that the users on the Swarm machines will generally not even notice that their computers are being used for rendering. A few words with regards to distributed rendering in general. So the general idea is that renderings can be broken up into many little tasks, which can then be distributed among the cores on your computer. The simplest way is by rendering small portions of the image, known as buckets. I'm sure all of you have a visual idea of what a bucket is, those small squares that appear on the image while it's being rendered. As each bucket is done, it moves on to the next one that is not being worked on by another core. And distributed rendering takes this idea, takes it a step further, and adds more cores by talking to other computers on the network. Through the local network, it gets all the data that it needs to render a bucket, send it back, and move on to the next one. V-Ray Swarm makes very distributed rendering easier than ever, as most of the communication over the network is done automatically. For example, discovering and adding render nodes, providing the same V-Ray version on all nodes, starting and stopping the rendering process, monitoring the CPU, GPU, and RAM resources per system, and so on. Swarm is doing all these things automatically. Swarm may be installed alongside V-Ray for Revit, but also may be installed on its own. You don't need to install Revit or V-Ray for Revit on a machine that you just want to use as a render node machine. You just need to install Swarm. Likewise, you don't need to install Swarm if you don't want the machine to be a render node. You can just install Revit and V-Ray for Revit without Swarm and still be able to render on render nodes that have Swarm. Here is the time to remind that in the V-Ray for Revit installer, you have the option to select whether to install Swarm or not. In order to use V-Ray Swarm, you need at least one additional machine with Swarm installed. So to run a Swarm rendering, there are a few small steps which you will need to complete. Note that this is done basically only once as an initial setup. After that, you will run Swarm in one click every time. These initial Swarm settings can be defined upon installation or from the Swarm tab in the V-Ray for Revit settings panel. So to access the Swarm settings, we need to enable Swarm from the checkbox over here. And since we are not running a rendering at this stage, enabling Swarm from this checkbox here will only give us access to the settings. We haven't run a rendering yet. And as you can see, the settings are grouped into three categories: resources utilization, network discovery, and tags. The don't use local machine option will exclude the local machine from the rendering process. However, Swarm will continue using a small percentage of the local machine's resources because it needs to communicate with the render nodes. But basically, it will not render on the local machine. The goal slider allows us to dynamically control the number of nodes that are performing the rendering. You can use this slider during rendering to add or to remove nodes. The number of nodes that are used for rendering is represented as a percentage of the number of all available nodes. Now, network discovery, by default, it is set up to auto-discover machines on the network, and this is how the master node is selected. And master node refers to the machine which can communicate with the greatest number of render nodes. Its role is to gather information about the machine's tags, V-Ray build, status, availability, and resources, and provide this information if a rendering request from the local machine is submitted. If we disable the auto discovery option, we can manually input the IP of the machine that we want to set up as master node. This is suitable in case there is more than one subnet in your local area network, or if you want to dedicate a specific machine to be the master node. Otherwise, it is recommended to keep it to auto discovery. And tags. Tags are used to group the machines on the network according to specific criteria. For example, you can tag the machines according to the office department they belong to, or according to their system characteristics like CPU or GPU type. Swarm will render with the group of nodes whose tags have been selected from the tags list, and to see all available tags in your network, you need to click refresh to see them. And I will show you how to configure render nodes and how exactly to tag them. And yeah, now from the Swarm tab, we can open the Swarm's web interface. Here we are. Our swarm network is pretty big, and yeah, you can either launch it from the button in the V-Ray for Revit UI, or the other option is to input the IP of the machine here, followed by 24267. This is the port that is used for communication. So currently we are in the swarm configuration of my, well, it is not of my local machine, but let's just select a node. And here on the right, we see some information about this node. And if we click on the URL, we will enter this specific node. And here we have a menu. Network is where we see all the machines from the network. We will go to configuration first. And to modify any of the settings here, you first need to disable the node from the button on the top right corner here. Now I can input a tag. So let's name this webinar and add it. And now I need to save the changes I made. I'm not going to cover the rest of the settings in the configuration page because I think they are very well explained on our documentation page. So I encourage you to just visit it. And now we can jump to the log page very fast. Currently it is empty. And once we start to render, a render log will be displayed here. And here we can check for information in case of errors and crashes. So in case your V-Ray swarm crashes for some reason, it is really good if you send us the V-Ray log that appears in the log tab. And as the name suggests, on the resource usage page, you can monitor the machine's usage for CPU, GPU, memory, network load, and storage in real time. V-Ray Swarm controls the distributed rendering on each render node machine. The actual rendering, however, is handled by V-Ray standalone. And on the versions page, we can check for the V-Ray versions that are available for rendering. And there can be more than one. I don't know why we can't see them in this case, but there can be more than one version, and you can delete specific versions or select the one that you want to use. Now let's go back to the network. Basically, during rendering, Swarm will check if the necessary V-Ray version is available on all nodes. And in case it is not, it will be uploaded automatically. Yeah, but it can be deleted manually. Now that we have tagged and configured one node, I can select, well, first I will enable my node, and I can select a few other nodes using Shift and Control. And I want to say copy configuration. And I will be prompted to disable the nodes first because otherwise we cannot copy the configuration. So I will disable them from the button here. Copy. Okay. And now we enable them again. And as you can see, the webinar tag that we created has been copied to the other machines. And now let's go back to Revit. And a few useful tips and tricks before we run the rendering. I will set the sampler to buckets. Why? Because distributing the render is more optimized for using buckets over progressive. Under optimizations, there is a control for the bucket size. And I forgot to mention, but the scene that I have has many lights into it. And that's why I make sure that the adaptive light setting is turned on. It is also under optimizations. Adaptive lights is a method which optimizes the rendering of scenes with many lights. And if we go back to the Swarm tab and refresh the tags, we are able to see the webinar tag, and I will now select it because I want to render only with the machines that are tagged with the webinar tag. And another useful setting when running a distributed rendering is the GR buckets channel. It renders an image with each bucket shown in a different color and a short text on each bucket naming the machine that rendered it. This channel is useful for accessing machine performance or for troubleshooting a distributed rendering process and so on. It is just recommended to enable it in case of error or something like this. Note that to use Swarm on multiple machines, a render node license is required for each node, but since Swarm is also supported in V-Ray for SketchUp and V-Ray for Rhino, in case you use any of them, you can use them as render nodes. And we are ready to run a Swarm rendering. Oops. I will just increase the resolution to something high and the quality to high as well. And I can render. And we don't have time to wait for the rendering, so I can continue with the presentation very fast. Yeah, I will continue with the presentation and we can see the image progress in a while. So almost at the end of this webinar, and a very quick summary. We saw how easy it is to explore different design options with the help of the V-Ray material editor. We saw how we can add even more realism to our images using the V-Ray environment effects, fog and the aerial perspective, and even more realism with the lens effect settings. And we can render way faster than before with the help of V-Ray Swarm, which is a distributed rendering system. We can utilize all machines in our office, even those that are not used for design, for rendering, and so on. And here is one of our top news, which has been announced recently. V-Ray Cloud is now in open beta. Everyone is welcome to join the beta and try it out for free at that moment. More info can be found on chaosgroup.com/cloud. The V-Ray 3.7 trial is available for all users who have previously downloaded a trial of V-Ray 3 for Revit. And if you already have a license for V-Ray 3, then you can simply update to V-Ray 3.7 for free. The build is available on the download section of our website, and recently we released a hot fix, so the most recent version of V-Ray for Revit is 3.7002. Make sure that you are using this version, and as it is the most recent one. For tutorials, help documentation, past webinars, and much more, check out our resource page regularly because we update it quite often. And once again, this is a reminder where you can find useful V-Ray related resources: our official website, our documentation page, and our YouTube channel. You can also join our forum. And if you found this webinar useful, don't forget to share it with your colleagues and friends once it is uploaded on YouTube. Thank you, everyone. Thank you for being so patient, and see you again.